So last class we talked about the atmosphere, and I want to just confirm that this first slide talks about the composition of the atmosphere, and then this next slide, because people were questioning, are the layers of the atmosphere. So this thin layer you see right here, this thin layer of atmosphere, has spheres inside of them, and they start with, so if I'm going to go right down here, the closest to land is the troposphere, and then as we move up is the strato, then meso, then thermal, then iono. So these make up that thin layer of the atmosphere, which is 71% nitrogen, 21% oxygen, and is full of gases, okay, other gases. But they are distinctive as you travel away from Earth. What I want you to remember, and I told you this yesterday, and that confused people as well, is that almost every topic, no, I take it back, every topic in this class, okay, other than the introduction of the layers of the atmosphere, will focus on the troposphere. So all the problems in the environment, global warming, acid deposition, fog, or photochemical smog, I said fog, they all occur in the troposphere, okay? Weather occurs in the troposphere. The only thing that we're going to learn about in this class that happens in the stratosphere is ozone depletion. You do not have to know distances of these layers, but you have to know what happens in them, which we went over yesterday. So today we're going to learn about the geosphere. So instead of layers of Earth, this should say layers of the geosphere. So please fix that. So we did atmosphere, we did hydrosphere, and now we're doing the geosphere. You have to know the composition of the geosphere, just like you have to know like the makeup of the hydrosphere and the makeup of the atmosphere. You want to think of iron, oxygen, magnesium, and silicon. What you will not have to know is specific components of each part of the geosphere's composition. Okay, I'll keep it just general. So what are the three parts of the geosphere? Who knows? Starting right here, the core, and then we move on. Mantle, and we move on. Good job. Core, mantle, crust. And we're going to learn about each. So the core, mainly iron, again, silicon, nickel, but we don't have to know this for the test. I'm being nice, okay? Eliminating major composition of each part. But what do we know about the core? Where is it in terms of the geosphere? Center. So think of C for core, C for center. It's going to be one of the parts of the geosphere that is subjected to extremely hot temperatures. So a lot of it is solid, but there's also a portion of it that makes somewhat of a liquid hot rock, okay? But we're going to think of it as more like a hot rock zone, okay? So we move away from the core and we're in the mantle. M for mantle, M for middle, M for good job. M for magma. So this layer, and you could see it, you see all the red is like flowing liquid rock. Even though it says mainly rock, it's liquid rock. So again, there's your composition. We could eliminate that from our test. We go from the center core to the flowing middle magma to the border, which is our crust. So it's the outside shell. Think of crust like the crust of your pizza is the border or outside of the pizza. It's the thinnest of the three parts of the geosphere. So when you look at it, it's very tiny. And I guess I could say this in the video because we're not going to be able to do this lab. If you looked at an M&M, the candy shell of the M&M would be considered the crust, right? And then we're talking about a peanut M&M. And then you've got the peanut would be your core, right? Okay. And the chocolate mantle. It's made up of plates. So the crust is filled with these plates. What do these plates do? They shift, but they're intended to do what? What does a plate do for you? Holds, okay? So the plates hold Earth in place, but when they shift, we have major problems. And that's the one thing I'm going to talk about problems of in this unit is the geosphere. Atmosphere and hydrosphere, we'll talk about those later, but we're going to talk about geosphere problems in this unit. So, actually, two more slides. So the geosphere is core, mantle, crust. Those are the major three components of the geosphere. But in between the crust and the mantle is a zone that they've named the Asthenosphere. And what does it look like is happening there? Here's the Asthenosphere right here. Here's my crust. Here's my mantle. What's this? What does it look like? It looks like what? Lava, but lava has to pour out of land. So and what do we know about lava? That it flows. That's what this is. It's a zone of flowing liquid rock. So magma, even though magma makes up the mantle, in the asthenosphere is how that magma flows across. And because of that flow is the reason why there's pressure on those plates. Because when it's concentrated, it applies a lot of pressure to the plates. When it flows, it could reach another area where it gets concentrated. So that's how it leads to the shifting. To clarify, magma is molten rock. The layer where molten rock flows heavily is called the asthenosphere. Magma is mainly found in the mantle, but the flowing magma is the asthenosphere. And then I want you to know about this. This sphere, lithosphere. So for years, when I taught AP Environmental, we had atmosphere, hydrosphere, lithosphere, which worked out great. A for atmosphere, right? A for air. L for land, L for lithosphere, and hydro meant water. Lithosphere only makes up the crust and the upper mantle. Okay, so they changed it to say that the three spheres of Earth are geosphere, hydrosphere, atmosphere. And then within the geosphere, you have the lithosphere, which is where the majority of our topic lies. We rarely talk about the core. We talk about the upper mantle because that's where the asthenosphere or the magma flows and the crust. Now, on Earth, there's two crusts. Anybody know what they are? Nope. Upper and lower would still make up the lithosphere. Look at my diagram. What do you see there? Okay, so water crust. What do we call that? Oceanic crust. And the land crust, which forms the major components of Earth, continental crust. Which one's bigger? How do we know this? How much more? Good, because 70% of Earth is water, so 70% of Earth's crust is in the water, or what we call the ocean floor, right? 70% of the ocean floor makes up the oceanic crust, or 70% of Earth.